Hello again, you lovely people out there. Today I want to talk a bit more about the Sting frame, one of the projects that I introduced in my previous video. And as you know, all of my projects go through the ideation phase, the concept phase, then the design phase, then the production phase, and then the flying trial run phase. As this project has already been going on for some time, I'm going to combine the ideation concept phase and the design phase into one video, which is this one right here. Alright, so the Sting frame, the target was that I wanted to have a 2.5-inch frame, so very small and light, with a 2-cell setup, and it should be with an all-up weight below 100 grams. So that was the target. And the different influences that I've had, one, and I already said that in previous video, one huge influence was the Instagram channel 250g FPV, or sub100g FPV, sorry. This guy is like, you know, constantly trying to go further with weight reduction and everything. And one element, of course, of his builds is that if he uses an HD system, which he often does, luckily, he strips the CADX Vista. And what he does basically is that he removes the heat sinks, the aluminium heatsink parts, and that reduces the weight by a lot. And that is one huge part of it. And he does also other stuff. I'll link the channel below so you can check it out. One post really caught my attention because it was showing a frame that he doesn't design and has his own frames cut, but instead he often does mesh-ups of frames that he just got a hand of in the past. And anyway, in this post, he showed a frame that had an interesting feature. And I'm not sure if that feature was meant to be the way that it was, or if he just made use of it the way that it was. But he had basically a main plate, and then he had two side plates. And in between the side plates, there was the battery. And one thing when I'm looking at the frames that are out there that always kind of annoys me is that a lot of frames look really awesome on the bench, but as soon as you put a LiPo on them or the battery on them, you know, that just kills the whole the whole look, and it's just way less appealing than it was before. And I'm very fond of frames that actually make use of the battery in the design, so that it basically the frame comes together as soon as you put the battery in. And that is something that I found really interesting when I was looking through Instagram and seeing his post. And that's basically when it all started, when I thought like, okay, I want to use of that, and I want to make a really lightweight frame, but I want to design the frame with the goal of making this all possible. You know, not just reusing a frame that is already out there, but specifically designing a frame for this use case. And also, one thing that was clear to me, I'm not flying analog anymore. I need an HD setup. So I wanted to have all of this, what I just said, like the sub-100 grams, 2.5-inch setup, and 2-cell battery setup. I wanted this all to work with the HD system. And of course, with the HD system, if you want to go lightweight, as I said before, you need to go with a CADX Vista that is stripped. And so that was basically the main influence. And I fiddled around a bit with Fusion 360, and I came up with something that I would like to share with you. So as you see, we're now sitting in front of the computer. So let's check out this frame together in Fusion 360. So ta-da! Here we are. This is the Sting frame. Let's swipe around a little so you can see it from all sides. All right, so as I said, and it was the inspiration to have these side plates and a battery in between. In this case, this is a 2-cell 450 milliamps battery. And as you can see up in front, we have the camera from the CADX Vista, which is like the normal DJI camera. So it's not the Nebula or anything. It's the normal DJI camera. And I also did that because the width of the CADX Vista camera it's just perfect for putting one of these 2-cell lipos behind it. And as you can see from the front, it's like a super slim setup, which is great. All right, so where should we start? Let's maybe start with the way that the side plates are mounted with the main plate. And the system that I've used here is something that I've used already like, I don't know, 8 years ago or so, on the first frames that I did. And the way that it works is that you, let me see, let's remove the side plates here. So basically you have these openings here, and the side plate just slides into them very snug, and they align nicely with the bottom here. And what you do is that you put an M2 nut right in here. You just push it in, and then you take a screw and you screw it in from below, and that creates a very tight connection. And I prefer these ways if you can screw these parts down. And I know there are frames out there where you just push it in and then it's supposed to stick well, and very often it works, but I wanted to have an extra way to screw things down. I've also seen ways where you, on the one side, you push it onto the frame and then you screw it down on the other side. But I feel like that causes a high risk of vibrations, and that is why I wanted to have another way to do this, and I much prefer this nut and screw way. If you use nylon nuts and screws, the weight is super minimal. If you want to have the extra stability with metal nuts and screws, you can do so, although I don't really see the benefit. Also, if you use nylon screws, this is a nice way how to suck up the force of an impact, because if you crash too hard, I think it's preferable that these nylon screws just snap away, and you don't damage the carbon or anything. All right, so this is the way that the side plates are being mounted to the main plate. About the side plates, if I remove the battery here, they also, additionally to the connection with the main frame, they also use the Calyx Vista to increase stability, and you have two metal or also nylon spacer bolts that are screwed in between. So this thing should really be super stable and stiff, but we'll see. Okay, then let's talk a bit about the center plate, and center plate. I was around when FPV just started, so I'm calling this stuff the center plate, which of course is not really modern anymore. It's called the main plate. All right, so let's take a look at the main plate. What do we have here? As you see, the goal was to keep everything very light, and that's why there are spaces in between, which are helping reduce the weight, while at the same time keeping enough elements to make sure that the overall stiffness is working. And if you look at the mounting options, you see it's a dual stack setup. You have one stack in the front with different options and one stack in the back. The stack in the back is supposed to be used with a Calyx Vista, and that is just 20 by 20, so that's fixed. And at the front, you see you have way more options, and this is where the flight control goes. And it starts with a 16 by 16 stack setup. Then it also has a 20 by 20 and a 25 by 20 by 25 by 25. And this 25 by 25 you can also twist at a 45 degree angle if you want to use a whoop board that would like to be mounted in this orientation. I prefer, even for whoop boards, I prefer to mount them straight and then just changing the alignment in Betaflight. This works perfectly fine. But if you feel like you're more comfortable with twisting it at an angle, then you're free to do so. And if you mount it at an 45% angle, you only have 3 screws to secure the flight control with, but that's perfectly fine. It's not an issue. A lot of Whoop frames are using this way, and that's perfectly fine. All right, then what we have is well, the battery is supposed to be mounted in between the side plates, as I said before. And if you use a little bit of foam on the left and the right, this already creates a pretty snug fit. But it's not 100% secure, especially in case of a crash. The battery could easily fly off. So what you can do is you can use these little knobs here, and you can use a rubber band and just, pull it over, and then you have a secure fit. Also, rubber bands are super cheap. Everyone has some at home, and then you can just put these over these little knobs. I put 2 in, so you have 2 positions where the battery is secured. So I hope that should work pretty well, but we will see in the end. Regarding motors, I did put in support for 9mm distance of the motor mounts and 6mm. So every motor kind should be supported well. In this image, the motors that I've put in here are most likely the motors that I'm going to use, which are the Flywoo Robo RB1205.5. I think 1205.5 is a really good motor size to use here, but more on that in the production video of this Sting frame. All right, then one additional thing, when you look at the, let's put it together here, and regarding the Cadex Vista air unit, I do not have a model of a stripped Cadex Vista yet, but you will see that the full Cadex Vista will just not fit. It is too high, and this is just not going to work. So if you want to build this frame, you really need to strip it. That's just the way it is. I mean, I don't know. I don't want to go too much into detail about the stripping the Cadex Vista, but of course the biggest concern is that not going to cause any issues with heat? I don't know of any stripped Cadex Vista that had issues due to this. The Cadex Vista does have a heat protection, so it switches off when it gets too hot, but I've never had that occur on my stripped Cadex Vistas, and I've not seen anyone using them. There is a certain risk if you, if I don't know, you crash into a tree and it takes you a long time to bring it back down and you can't disarm and remove the battery, then maybe it could overheat, especially if, I don't know, I've seen some people switching off the heat control, temperature control, and then you might run into problems, but I will include something in my build that I'll show in the construction video that helps with that. But more about that in the construction video. All right. Anyway, one other thing that is noteworthy about the frame is that I plan to use one of the flight controls that I really like, and that is the Chehamsu. I don't know how to pronounce that, but that's the best I can do. Chehamsu, all-in-one board, and this board is larger than the usual boards are. It is longer. And it includes the ESCs and the flight controller on a 20x20 mounted stack, which is the first that does that, as far as I know. And I have used this on other builds, and I really like the form factor and how easy you can set it up. So that is what I will probably be using on this setup, and the frame supports these larger boards perfectly. All right. So much about that. There is one additional thing that I want to show you. That is not necessarily the main use case that I plan on using the frame with, but I also designed a optional top plate. Let's see here, and let's switch off this. This top plate is just a way if you don't feel like the side plates are your thing, then you can mount these or mount this top plate with normal spacer bolts, and then you just have a different way how to build the frame. I did this because I also want to build a 3-inch version of this frame, or design a 3-inch version of this frame, and this 3-inch version I plan on using as a long range setup with two 18650 lithium ion cells, and I don't know if that works or not, but I want to try it out. And in order to mount them nicely, I need such a top plate. And if anyone else wants to do that or has other batteries you want to use, then this top plate is something you can have CNC cut as well, and then you get the whole package. All right, then one more thing that I just remembered I wanted to tell you is about the 3D printed parts. And actually this frame, compared to many other of my designs, does not have any 3D printed parts. Instead, one little helper, and that little helper is the antenna mount. And this antenna mount, I designed it in the smallest lightweight possible, but still providing enough security for the whole setup, because the issue with antennas that are just sticking out at the top without any way to secure them is that in case of a crash and you or not a crash, but you fly through a narrow passage and the antenna gets stuck at the top, then this could rip off the pad of the antenna from the Calyx Vista board. And in order to not have this issue, what you do is you put your antenna, you align it here, and then you use a zip tie to secure it nicely. And this way, if you crash, the zip tie will make sure that the pads are not going to rip off. So that's always something which is helpful. And it prints very nicely. Yeah, but I'll show you more about 3D printed parts in the next video, which is about the production. This video was about the design, but I think I've said everything I wanted to mention. The Calyx Vista camera is nicely secured here on the front between the side plates. So if there is a crash, the force goes onto here and will secure the camera nicely. And as I said, if the crash is too hard, if you use nylon screws here, then these will just snap off and this whole thing will just be bent backwards. But that's, as far as I can tell now, this is the worst that could happen on a crash for endangering the Calyx Vista camera. All right, so that's about the design. I hope I said everything, but I think I did. If you have any questions about the design, please let me know. All the design files are going to be available on Thingiverse, and I'll put the link in the description down there so you can just download it yourself. Yeah, you can have it CNC cut by your favorite workshop. I don't know. It would be interesting to hear what you think. Please let me know. And I will continue with, in the next video with, when I have everything CNC cut, I have the parts here. I'll go with you through putting everything together, which parts I chose and all of that. So, if you're interested in that, stick around and check out the next video. Until then, have a good time. Bye bye.